Welcome to the course Digital Transformation and Technological Innovation. So, we are into our fourth module, that is Tech Advancement and Internet Basics. So, let us continue our discussion from where we left. So, now we have covered the tech advancement part, lots of components, innovation in chip designs, semiconductor material, quantum computing, and all those aspects we have already covered in the previous sessions. Now we move to the internet part, that is internet basics. So, first let us start with the definition. What is the internet? So, internet is a global network of interconnected independent networks that uses standardized networking protocols. Now, what it does? It facilitates communication and resource sharing among billions of computational nodes. So, this network of networks essentially is connecting lots of computer systems and other computational nodes. Any device which has some sort of computational capacity and has the networking capability can be connected to this network of networks, right, and therefore it will also be counted as a computational node in that sense. So, it is a global network. That means pretty much all the networks are connected to this global network, right, and protocols for communications and other aspects are pretty much standardized. And the main thing that is happening through this internet, which works more like a infrastructure, is that communication and resource planning, resource sharing, communication across the network, communication between computational nodes, and the resource sharing across the network, that is something that is being facilitated. So, facilitates communication and resource sharing among billions of computational nodes. Then functionally, if we look at internet, then it works like a distributed system. So, functioning structurally as a distributed system, because there are different computing nodes connected via network. So, essentially a distribution of computing node in a way we can visualize, and obviously this is a global network. So, local networks then they connect to the global network, right. So, essentially a global network of interconnected independent networks. Now, these independent networks for any given organization, they might have their own internal networks, and then they would be connected to the internet also. So, essentially an organization network would be an independent network. Now, connecting for simplicity, let us just think about all the organizations that are out there which are having their own internal network. So, let us think of all those networks, and we can consider them as independent networks, and because they are connected to the internet, so that means interconnection is there. So, interconnection is there. So, all these organizations internal networks or independent networks, if they are connected, and a global network can be formed. So, essentially an internet, when we say internet, we are essentially talking about this network, which is a global network of interconnected independent networks. And as I said, the main idea is to facilitate communication and resource sharing among billions of computational nodes that become part of this network of networks, right. Now, functionally they work like a distributed system, right. So, in a distributed system, what happens, that we will see in the coming slides. So, distributed systems and with this decentralized governance. So, there is no centralized authority, there is no single owner that is actually governing this network of networks, this global network of networks, right. So, this is decentralized, no centralized authority, that means no ownership there, right, and it is distributed in nature. So, therefore, the computing is splitted, part of the computing happens at one node, other part of the computing happens at some other node, right. So, it is a distributed system. So, let us move forward. Now, what are the attributes or what are the things that characterize the internet? So, let us look at some of those things. So, first is hardware agnostic interoperability, right. So, one defining feature of internet is the interoperability that it provides, because there are all kinds of computing devices with different hardware, manufacturers of those hardware are also different, and they might be following different hardware standards, Then there are operating system which are also, there are so many of them, and they might not be compatible with each other easily, and so that is a challenge. And then there are software software applications which might also be different, because they are running on different hardware, running on different operating systems, right. So when there is this kind of heterogeneous computing environment environment is there, then how do we create a network which is functional, right, which can still work in such a environment? So how do we ensure interoperability? So internet actually does that through its own standardized networking protocols. It is able to achieve the interoperability. So this is one of the defining feature, that so many different kind of devices with different kind of hardware, different kind of operating system, different kind of applications, still they when they connect to the internet, still they can function, still they can interoperate. So hardware agnostic interoperability. So irrespective of the hardware that is there in the computing devices, is still the communication and resource sharing, right, the two things that we talked about, that is being facilitated via internet. So communication and resource sharing should still work, right. So that is one important defining characteristics, hardware agnostic interoperability. So enables, so what it does, enables computer system with disparate CPU architectures. CPU architectures would be different for different hardware, byte orders, right, the way data is stored, that might be the ordering might be different, operating systems could be different. So all the hardware and the system part that is there, that can be very different from one device to another device, and so enables computer system with these kind of disparate CPU architectures, byte orders and operating system to exchange raw binary payloads seamlessly. So still the exchange of information, exchange of raw binary data, seamless fashion can still be facilitated through internet, the kind of standardized networking protocols that it follows. So still this exchange can happen. So hardware agnostic interoperability is one defining feature. Then the second is logical topology abstraction, right. So what this is about, it hides, it abstracts away, hides or abstracts away the physical cabling and the infra that is there, and and what we actually see, a unified virtual internet protocol for addressing. So we deal with a unified virtual internet protocol for addressing. So behind that, all the physical cabling and infra is abstracted away, or hidden, right. And this addressing scheme, unified virtual internet protocol, that this is this, through this addressing scheme, we are able to manage this abstraction. So logical topology abstraction. So every device is addressable because of this abstraction that is there, unified virtual internet protocol for addressing, right. So everything, cabling, infrastructure can hide behind that, right. So this is another important characterizing feature of the internet. Then next is extended inter-process communication, right. So because communication is happening from one computational node to another computational node over the network, right. So how this it is the same process that is starting from one node, and it might end on another node which is across the network. So how this inter-process communication will happen? So that is something that is extended by the internet, that is its another defining characteristics. So it projects memory to memory and program execution boundaries beyond a single logical motherboard. So beyond a single computational node, it is internet through the network is able to project memory to memory or program and program execution boundaries beyond a device, beyond a motherboard, and takes it across the network to another computational node, that means another motherboard, right. So extends the inter-process communication. So the part of the process can happen at one motherboard, and the part of the process can happen at the other motherboard across the network at other computational node. So, this is another thing from the inter-process communication point of view. So, the communication happens across the network, right. Next, defining feature is distributed state consensus. So, what this is about? So, it internet it supports the coordination among independent computing nodes to synchronize data and operate as a unified logical system, right. So, between computing nodes we are talking about the distributed computing setup, and that will discuss in more detail later. But in the internet itself, this distributed state consensus happens, and because of that, essentially what it means is that the coordination between independent computing nodes in terms of synchronizing data, because the data will cross across the network. So, some sort of synchronization can happen so that the coordination is facilitated, right. So, that is done through network standardized network protocols, and because of this essentially we can say that as if everything is operating as a unified logical system, right. So, we are able to synchronize data, we are able to manage the data and minimize the data losses that can happen due to the network, right. So, therefore, this is achieved, and therefore, distributed state consensus. So, there is a consensus mechanism that can happen between two independent computing node across connected via network, right. So, that the data synchronization is achieved. So, this is another defining characteristics of internet. Then next is decoupled compute and storage, right. So, what it does, it separates execution logic from physical data persistence using network bound file systems, because data might be at data might be residing in some other computational node, some other computing node across the network, right. So, how you connect the execution logic to the data, because in a single computer the storage is directly connected and the CPU is able to fetch that data, bring that into memory, and then execution happens, right. But here the data might be somewhere else in some other computational node across the network. So, in a way internet is able to separate the execution logic from the physical data persistent. So, how? Via network bound file systems. So, because network file systems are there, and through that logic that is there in the network file systems, this separation of execution logic and this physical data, that is managed, right. So, whatever data is needed, that is managed through network file systems, and therefore, for the execution context it might feel as if there is access to the data, just like it is the case with the single computational node, right. So, network file system do the trick, and they help in a way decouple compute and storage, right. So, this becomes another defining feature, right. Next is universal packet switching, right. So, in universal packet switching, what happens, internet is able to route arbitrary chunks of data dynamically without requiring dedicated physical transmission circuits, right. So, there is no dedicated circuit, no dedicated connection between two computing nodes across the network, and through a universal packet switching mechanism, the routing of chunks of data packets is done dynamically, right. So, this essentially improves the the network utilization, network efficiency. So, network efficiency gets improved. So, therefore, the network is able to support lots of transmission of data across the network that might happen between computational nodes, right. So, universal packet switching essentially is important in terms of managing the data traffic across the network. So, routes arbitrary chunks of data dynamically without requiring dedicated physical transmission circuits. So, this is another defining feature of internet, that right that network efficiency is managed, the data traffic is managed through the network, and because there is a universal packet switching mechanism that helps this. Moving on. So, this was about the internet being a global network of network, communication and resource sharing is there. So, we talked about that. So, overall this is a distributed system, internet works like a distributed system. There are some defining features that we talked about: interoperability, the abstraction of the physical part, and then the interprocess communication, then the consensus for the data that is moving across the network, and then network file system. So, because of that, decoupling of compute and storage, and then universal packet switching to manage the data traffic. So, all these important features define the internet, and that is why it works. Then how internet services are provided. So, how end users they are able to access the internet services. So, few details about that. So, essentially more often than not telecommunication firms bear this responsibility, or it is the telecommunication firm which provide the internet, and therefore, they act as internet service provider. So, apart from telecommunication firms, there might be other firms also which might be doing this business of being an internet service provider. Most of the coverage is actually most of the market is actually captured by telecommunication firms. So, essentially we can say that telecommunication firms act as internet service providers and give internet access to end users, right. Now, because there are so many telecommunication firms, so obviously they will mainly be managing the network or running the network for their own customers, right. So, how customers of one telecommunication firm will be connecting to computational nodes in that are part of some other telecommunication firm. So, there has to be a mechanism, right. So, these ISPs, so these telecommunication firm acting as ISPs. So, in general we can say these internet service providers or ISPs connect to one another. So, they need to connect to one another, so that a computational load in one ISP is able to connect or communicate with a computational node in another ISP. So, ISPs connect to one another and exchange internet traffic, right. So, there is exchange point for internet traffic, right, and if you recall that we talked about the co-location services. So, and we also talked about in the cloud context that some of the companies which were into managing the exchange for internet traffic, they also became cloud provider, right. So, essentially because they have to manage the networking, power, cooling and all that infrastructure. So, because of that something that they are already doing, either they are ISPs or they are running the co-location services for internet exchange, they are able to extend their services in the towards cloud market as well. So, ISPs connect to one another and exchange internet traffic, and that is why computational node or from one ISP to are able to communicate to computational node on another ISPs, right. So, this ensures that one computer's masses, so this exchange that happens between ISPs, this will ensure that one computer's messages reach the other computer that is online and waiting to communicate, right. So, therefore, the global network of networks is actually formed because of these exchanges, internet exchanges that are there. So, ISPs connecting to one another and exchanging internet traffic. So, those points where this is happening, those exchanges where this is happening are actually connecting the networks. So, global network of networks, essentially those networks can also be referred to as something that is run by individual ISPs. Essentially we are connecting the networks run by in a way individual ISPs, and that is how the global network is formed, and that is how the internet is formed. So, this was about how the internet services are provided. Moving on, here we have a nice graphic to explain the complex scenario that is there in terms of global network of networks, right. So, let us say this is your organization, right, you are here, and your organizational departments, department 1 users, there would be number of PCs, they will be connected to LANs, and department 2 there will also be number of PCs, right, they will also be connected to LANs, and this LAN will be connected to the core network backbone, and then there would be wireless subnet that will also be there in a organization. So, the machines would be connecting to this wireless subnet, right. So, this is also part of the core, this wireless subnet is also connected to the core network backbone. Then for the guest and visitor also, and the for the devices of guest and visitor, that will also be given access temporarily through the organization's network wireless more often than not, right. So, this is there. Then if we look at this core network backbone is connected to the security gateway. So, everything connects to this core network backbone of the organization, and this connects to security gateway here, and then the security gateway will actually protect the organization network. So, so this is more of a hardware level security gateway, and lots of unwanted traffic can actually be filtered out through the security gateways. So, more important from the security point of view. So, right. So, then this is connected to the generic gateway, right, and here internal server of the organization is also running, which is also connecting and which is also directly connected to the gateway, because visitors from outside would be looking to access this website which is run by this organization, right. So, it should also be directly connected to the gateway, right. So, that is what it is has been shown here. Now, from this gateway there would be typically organizations they do their own risk management for internet connections. So, they generally take more than one connection. So, they take services of more than one ISP in a way. So, primary connectivity, that might be an ISP 1, and then secondary connectivity, that might be ISP 2, right. So, in case ISP 1, that firm is facing some technical issues or their network is facing technical issues. So, the organization should not lose access to the internet, and therefore, secondary connectivity can ensure that they are still able to connect to the network and operate, right. Then these lines, whether the primary ISP or the secondary ISP, they are connected to the global network cloud. So, this global network cloud, we can put all other ISPs here, all other organizations here, which will be connected to all other ISPs that are out there, and internet exchanges including. So, everything goes back here. So, just like we talked about the case of this organization, similarly you can think of thousands of organizations somewhere in this cloud, including the ISPs, the internet exchanges and everything will go here. Examples of some of these organizations, you can see partner site 1, right, resource database. So, this is also just like this organization, that is expanded form we saw for them. The we are looking at the closed form, partner site 1, resource database, right. So, this is connected here, government sites connected here. So, these are all example of other organizations which would also be connected to this, right. Then there might be other examples are also there, right. So, this is another site, and IoT devices are connected, off campus remote station, and external linkages you can see. So, this is also being shown here as another campus location, and you are trying to connect. So, this is how the internet actually looks like. So, global network of networks. So, let us move on. Now, we come back to the question that what is the internet. So, essentially after doing that discussion, now it is very clear that internet enables, so it is more like infrastructure, and it enables and houses distributed computing implementation. So, while it provides the global network of networks, essentially this network is being used to run to perform distributed computing, right. So, essentially lots of distributed computing implementations have happened, and for different all organizations in one way or another, if they are running a websites, they are doing a distributed computing implementation on top of internet, right. So, it is the internet that is acting as a platform and supporting and housing the distributed computing implementation. So, example is World Wide Web, right. So, all the websites for websites for all the organizations, there are so many thousands of websites. So, all those are examples of distributed computing implementations, and right, and the cloud computing. So, all the cloud vendors, they are also providing cloud computing. So, that is also in a way distributed computing implementation, being supported by internet as a platform, being housed by internet as a platform, right. So, internet is now, from here it should be clear that internet is more like infrastructure, it is more like a platform infrastructure or infrastructure platform which supports lots of distributed computing implementation, because the internet itself is a distributed system in a way, and it supports and houses distributed computing implementation, which examples are like running websites, World Wide Web or www or simply web. So, these are the different names that we refer to this kind of distributed computing, cloud computing, and then there are other similar examples of implementations that are there that we will be discussing. Then when we said distributed computing, then what is distributed computing that we have referred to so many times? So, distributed computing is a computing model where independent computational nodes, right. If you go back to our internet definition, so here also we said independent networks, and here we said computational nodes, right. So, coming back here, so this is a computing model where independent computational nodes, right, and that means these nodes are running on their own independently, right, and they are connected via a network. So, internet is a network of networks. So, connected via network and communicate via message passing and coordinate actions to fulfill shared task. So, there is, because they are connected via a network, so the only way to communicate, one way to communicate rather is via message passing, and message originating from one computational node and it is being received by another computational node, and that is how the communication will happen, and through that communication they will coordinate action to fulfill shared task. That means those shared tasks might require part of the computing to happen at one computational node and the part of computing to happen at another computational node. So, the communication will happen via message passing, and the coordination for that computational node for that shared task will be done, right. So, essentially distributed computing is another model where computing is not happening at a single machine, rather it is happening at more than one machine or at least two machines connected across the network, right, part of the computing at one node, part of the computing at another node. So, this is the computing model, that is actually distributed computing model, that is actually running all the distributed computing implementation like websites, cloud computing and many others, and internet, the network of networks that is there, the global network of networks that is there, that is facilitating all these distributed computing implementation, right. Now, for the user, distributed computing will appear, it will be presented as if it is a single coherent system. So, to a user it will be a single coherent system, right. So, essentially the internet and the distributed computing essentially operate in this manner. And next that we are planning to discuss is about different architectures that might be there in the distributed computing implementation, but we will take that to the next session. Thank you for now.